Hi, my name is Myra, and my project is a proportional meta-analysis of the disease burden of rhinovirus and enterovirus on patients before and during the COVID-19 pandemic. So first of all, what are rhinoviruses and enteroviruses? Well, rhinovirus is a single-stranded RNA virus that is the predominant cause of diseases like the common cold. It is typically present in the nasal area, which is why they're known as nose infections. Enterovirus, on the other hand, are also single-stranded RNA viruses, and they can cause diseases like hand, foot, and mouth disease and meningitis. So they're typically present in the intestine, which is why they're known as intestinal infections. Rhinovirus and enterovirus are grouped together in my study because when you test for them, whether through throat swabs or nose swabs, it's really hard to differentiate between the two, which is why lots of published studies group the two together. So these viruses are important because of three main reasons. So they have a high morbidity, there are no vaccines available, and they're unpredictable during pandemics. And we're going to dive into each of these. So first is high morbidity. So morbidity is a condition of suffering from a disease or medical condition. And according to the National Institute of Health, over 1 billion people are infected by rhinovirus and enterovirus every year. About 2.5 million people are killed by diseases caused by rhinovirus and enterovirus every year, and these high numbers make it very crucial that we have a solution for them. However, there are actually no vaccines available for broad protection against these viruses, and this is due to the fact that there are over 160 serotypes for rhinovirus and 100 serotypes for enterovirus. And the numerous serotypes of rhinovirus and enterovirus make it nearly impossible to develop a vaccine that provides broad protection against all of the strains, since each strain has a little bit of a different genetic makeup from one another. Therefore, no vaccines actually exist to prevent rhinovirus or most enterovirus infections except for the polio vaccine. So since there is no vaccine that is available, it's really crucial that we be able to track the trends of rhinovirus and enterovirus so we can prepare for them. However, since the recent pandemic, they have been hard to track. So in the past, before the pandemic, rhinovirus has typically peaked in the spring and fall, while enterovirus has peaked around the late summer. And the COVID-19 pandemic disrupted this established pattern, and this may be due to the introduction of a new virus and new public health measures. So current studies that have looked at rhinovirus and enterovirus actually have different results on how they functioned during the pandemic. So as you can see in this study by Rankin in 2021, the top graph shows rhinovirus and enterovirus, and the pandemic period is marked by the highlighted period. And at the beginning of the pandemic, there was a sudden drop in rhinovirus and enterovirus. However, it eventually returned to its regular rates. In this study by Ma in 2022, the bottom line represents 2020, which is the start of the pandemic. And as you can see, the rhinovirus and enterovirus never returned to the regular rates in the year 2020 like it said it did in the previous study. So this conflicts with the last study. And this last graph is a study done by Spiker in 2023, and it shows that there was a sudden decrease in rhinovirus and enterovirus at the beginning, but then a rhinovirus and enterovirus returned to their regular rates eventually. So these studies all had conflicting results, and it makes it more apparent that understanding these unpredictable trends may actually give us insight to public health mitigation to rhinovirus and enterovirus in the future. So being able to track these viruses is very crucial. So that brings me to my research goal, which is to statistically analyze data from multiple independent studies in a meta-analysis to make accurate and reliable conclusions about the disease burden of rhinovirus and enterovirus on cases before and during the COVID-19 pandemic. And my hypothesis is that the disease burden of rhinovirus and enterovirus decrease, and I believe this will be due to the public health mitigations that were put in place because of the pandemic. So for my methods, I did a proportional meta-analysis, which is a method that combines results from different studies to calculate the overall proportion of people affected by something like a virus across multiple studies. So this followed the PRISMA guidelines, which are used for meta-analysis. So I began by performing a systematic literature search across several databases, which were PubMed, Embase, and Medline. And I chose these databases because they're all biomedical literature and they all rely on peer-reviewed articles. After finding my studies, I defined inclusion-exclusion criteria to determine which studies to include. And the studies had to involve detection rates of RV/EV. They had to state its sample size, must state their setting, must state data in raw numbers, must be conducted between 2010 to present, and they also must be a reliable peer-reviewed article. So if the study lacked any of this criteria, I excluded it from my study, and if it follows all the criteria, then I moved on to the next step of putting it into a data extraction table. Then after the data extraction table, I performed the analysis in R statistics using the meta package and metaprop function. And then using those functions, I was able to generate a forest plot for the pre-pandemic data set and a forest plot for the during pandemic data set. And following those, I created a funnel plot to assess the potential publication bias for both groups. So here are my results, and this is the data extraction table, and it summarizes the key studies on rhinovirus and enterovirus studies that were in this project, and it also includes the case counts from before and during the COVID-19 pandemic, and lastly it provides overall the foundational data for analysis. Here is the forest plot of rhinovirus and enterovirus cases before the COVID-19 pandemic, and as you can see, the pool estimate is circled and it's 37% with the confidence interval from about 17% to 57%, and the heterogeneity suggests that there is a strong variation across the studies, and the pooled estimate actually is the positivity rate, so about 37% was positive. Here is a forest plot for during the COVID-19 pandemic, and it has a pooled estimate of about 33% with a confidence interval from 15% to 52%, and the heterogeneity remains high at about 99.9%. Here is the funnel plot of rhinovirus and enterovirus before the COVID-19 pandemic, and this basically assesses the publication bias, which is the failure to publish the results of a study on the basis of the direction or strength of the study findings. And the points are expected to form a symmetric inverted funnel shape if there is no publication bias, and some asymmetry or spread may indicate that there is some potential publication bias, which can be seen a little bit in this funnel plot. This funnel plot shows positivity rates during the COVID-19 pandemic, and as you can see, it is much more symmetrical than the previous one, and each dot in this graph actually represents the study, and now they're more even. And this shows that there is a lot less to no publication bias in these group of studies. So what do these results mean exactly? So looking at the forest plots, we can see that the RV/EV positivity slightly decreased during the pandemic from going to about 37% to 33%, which is a bit of a decrease, but it's only a 4% decrease, so the rates remained relatively the same or high overall. And the high heterogeneity shows that there is a high variation among the studies, which can be analyzed and broken down further in subgroup analysis. So the real-world application for this is that RV and EVs continued circulating despite the pandemic precautions, which shows their strong transmissibility and potential burden. So here are the funnel plots. So the before pandemic funnel plot is uneven, which shows that the studies had different results and may have used different methods, while the during pandemic is more balanced, which means that the studies were more similar and followed more consistent testing and reporting. So the real world application for this is that this shows that during the pandemic, public health efforts improved how data was collected, and keeping those systems in place could help track viruses better in the future because it helps data analysts by having studies that are more consistent, making it easier to compare studies to one another and track disease burdens. So the real-world implications are that rhinovirus and enterovirus continue to spread during the pandemic, and that there is lower variation in publication bias among studies during the COVID-19 pandemic, which reflects a time of heightened scientific collaboration and standardization in research practices. And furthermore, by looking at data by age, gender, and race, we can actually see if certain groups were more affected than others, which could be good for future research. So some limitations in future research. So the COVID-19 pandemic was fairly recent, so there aren't that many studies that analyze the positive rates of rhinovirus and enterovirus during the time. And many studies actually didn't report information on patients' age, gender, or race, which makes it hard to understand how the viruses affected different groups. And lastly, all of the included studies were written in English, which could prevent other studies that had helpful information from being included because studies that were not in English were not able to be used. So as more studies are published over time, future research should focus on diverse subgroup data and include global sources and explore long-term virus trends across different communities. So thank you for listening, and here are my references.